This is 9.6 in your book, day 2 on this. We're talking about angles of elevation and angles of depression, which are lovely words. But once again, we are using trigonometry to solve problems. So what is our lovely little mnemonic that we use to help us set up trig problems? SOHCAHTOA. SOHCAHTOA. And again, there's little equal signs in between the sine of your angle, cosine of your angle, and tangent of your angle to make sure that we have an equation that we can solve. So first of all, let's talk about angle of elevation. Angle of elevation is when looking up to an object. The angle of elevation is formed by an observer's line of sight and the horizontal line. So when we talk about angle of elevation, it's in reference to, hey, from parallel to the ground, if you're looking out just parallel to the ground, how much do you have to tilt your head up to look at the top of your object? That would be how much you have to elevate your head, okay? How many degrees do you have to elevate your eyes to look at the top of the object? So that's angle of elevation. So this is a picture of Casey. He's sighting the top of an 84-foot tall lighthouse with an angle of elevation of 58 degrees. So he has to tilt his chin up 58 degrees. So we get this triangle, so to speak. I'm just going to simplify it here. We have an 84-foot tall lighthouse, and he has to tilt his chin up 58 degrees. How far is he standing from the base of the lighthouse? So we want to know how far away is Casey from the lighthouse. I'm just going to call that distance x. All right, so, oh, this is sort of interesting. It also says that Casey is 6 feet tall. Casey's pretty tall kid there. So my question is, how 84 is the height of the lighthouse, but he's 6 feet tall. 84 is not the right number here. Yeah, we got to subtract the 6. 84 is the whole height of the lighthouse, but our side of our triangle doesn't include his 6 feet of height. So what should we have there? Not 84, but 78. Yeah, 78. Oh, it's just looking from horizontal up. That's the angle you elevate your chin. Oh, hey, Stuart. Is this your water bottle? Yeah? I think it's been here. It's been here a couple days. Here you go. All right. So, 78. Oh, I'm glad I looked at that. I was like, what's going on here? Okay. So now that we know that the side of the triangle here is only 78 that we're looking at, we have an angle here at 58 degrees. Which trig function should we set up? Opposite over adjacent. Very good. Opposite over adjacent would be tangent. So we want tangent of 58 degrees equals opposite over adjacent, 78 over x. How do we solve this? Cross multiply. Very good. So we get x times the tangent of 58 degrees equals 1 times 78, or 78. How do we get x by itself? Divide by the tangent of 58. Okay. Divide by the tangent of 58 degrees. Alrighty. And you told me you got what? 48.7 feet. So he is 48.7 feet away from the lighthouse. Okay. All right, let's look number 2 here. The angle of elevation from a kicker's foot on a football field to the top of the goalpost bars is 17 degrees. So I've got a football, we got the ground, and the kicker to the top of the football 17-degree angle of elevation there. He is standing 131 feet from the base of the goalpost. So 131 feet from the base of the goalpost. We want to know how tall is the goalpost. So should I be using my my hypotenuse here, or are we trying to find the vertical? Yeah. So there's our x to find the height of the goalpost. Tangent function again, opposite and adjacent. So tangent of 17 degrees equals opposite x over adjacent 131. How do we solve?
131 times 10.
Yeah, 131 times the tangent of 17 equals 1 times x, which is x. And we just get to plug that right into our calculators. What do you get when you plug that in? 40, thank you, 40.1, and we're talking feet here. So that height of the goalpost is 40 feet tall? That's pretty tall, yeah. All right, let's look at number 3. Leah's mom is standing at the bottom of a slide at the playground. So she's standing right here at the bottom of the slide at the playground, waiting for Leah to slide down the slide. If the angle of elevation from the bottom of the slide to the top, so she's at the bottom and she's looking up to the top, it's 46 degrees. And the slide has a vertical height of 9 feet. So that must be our vertical here is 9 feet. We want to find the length of the slide. Are we trying to find the distance to the slide, or we need to find the horizontal, hypotenuse there? All right. So which trig function are we going to use now? Sine. Opposite over hypotenuse there. Opposite over hypotenuse is sine. So we're going to do sine of 46 degrees equals opposite 9 over hypotenuse x. How do we solve for x? Cross multiply, my favorite thing. So we get x times the sine of 46 equals 9. And how do you get x by itself? Sine, thank you for correcting. Sine, divide by sine of 46. Good. So the sine of 46 cancels out, and what do you get for x? 12.5 feet. 12.5 foot long slide. Great. All right, let's do number 4 also, because it's a little different. A dog is standing 5 feet from the base of a tree. So here's our doggy. He is 5 feet away from the base of a tree. So here is our tree. Looking up at a cat that has climbed 16 feet up in the tree. What is this vertical that we're looking at?
Tree.
The tree, how tall is 16 feet up? Very good. What is the angle of elevation? Shh, guys, quiet please. What is the angle of elevation? Where's our x in this problem? It is the angle. We want to know the angle of elevation from the dog to the cat. It's asking what is the angle of elevation. So we're actually finding the angle here. Just like yesterday, what trig function can we set up? Opposite over adjacent, that would be tangent. So the tangent of our angle that we're trying to figure out, this is the tangent of x, equals 16 over 5, opposite over adjacent. From yesterday, how do we free the x here? It's trapped. How do we free that x? We can't divide by tangent. It's not a number. It's a whole entire function, a collection of things that have happened. How do we get rid of the tangent? How do we undo tangent? The inverse. Very good. Tangent inverse. We're going to do tangent inverse of both sides. Tangent inverse and tangent undo one another to free the x. So we get x equals the tangent inverse of 16 over 5. So you can type that into your calculator. What do you get? What mode should you be in? Degree. Degree mode. Make sure you're in degree mode. All right, we're going to type it into our calculator, making sure we're in degree mode. So tangent inverse of 16 over 5, and what did we get? 72.6 degrees. So the angle of elevation, that dog is looking up pretty high there. All right, so angle of elevation is looking from horizontal. How much do you have to tilt your chin upwards, okay? Questions on those? All right. We won't do all of these, but angle of depression is formed by the observer's line of sight and a horizontal line. So again, you're looking out horizontally. If you have an angle of depression, that means from horizontal you have to look downward a certain number of degrees. Now, what the real interesting part here is, you got a horizontal line of sight. Normally, you're looking straight ahead. Well, that line of sight that's normally horizontal is typically parallel to the ground, okay? So what you can look for oftentimes with angle of depression is alternate interior angles, okay? So that's something we're going to pay attention to. All right, we will point those out in just a bit here. So let's look at this one. A lifeguard, here's our picture. A lifeguard is sitting on a platform looking down at a swimmer in the water. So there's that swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground, so he is sitting 8 feet above the ground, and the angle of depression to the swimmer is 18 degrees. From horizontal, he's having to look down 18 degrees. How far away is the swimmer from the lifeguard? We want to know how far away is that swimmer from his tower. We're trying to find that distance x. Alternate interior angles. Yeah, I want to simplify this picture, clean it up just a little bit here. I'm going to redraw. Here's our tower. It's 8 feet tall. Here's our swimmer right here. We're trying to find how far away he is. And we have this angle of depression from horizontal looking down. 18 degrees is how he looks to find the swimmer there. So this is the key. We have this horizontal here that is parallel to the water level. And you see the Z shape here. Here, these two angles are alternate interior angles. So this is also 18 degrees. All right, so we get that alternate interior angles are congruent. Now we have a triangle. We have all the parts we need to set it up. Here's our angle we're looking from. So again, opposite over adjacent is another tangent function. So tangent of our 18-degree angle is opposite over adjacent. That's going to be 8 over x. How do we solve for x? Cross multiply. So x times the tangent of 18 equals 1 times 8, or 8. And then how do you get x by itself? Divide away tangent of 18. So the tangent of 18 can fully go away. And 8 divided by the tangent of 18 is? 24.6 feet. So that swimmer's 24.5 feet out in the water. Okay. Questions on that one?
No.
All right. Let's look at number 7 and 8. Those are the last two we'll do. Number 7 and 8. Building A is 480 feet tall. Here's building A. Please, you should be drawing a picture. Building A is 480 feet tall. I'm going to put a 480 on there. Building B is 654 feet tall. So here is building B. It is 654 feet tall. The angle of depression from the top of building B, so from the top of building B, normally we look straight out, but then we have to look down to building A. That angle of depression downward is 42 degrees to sight the building A. 42 degrees there. How far apart are the buildings? Oh, well, look at this. I can just sort of make a right triangle there. I'm trying to find how far apart they are, so I really want this distance x between buildings A and B. I need some more information in my little triangle shape that I have here. Can I figure out this distance? Yeah, 654 minus 480. What is that? Yeah, so this is 174 feet. So 480 plus 174 would give us that 654. All right, so I had to do a little bit of subtraction there. Now I have a triangle, and my angle of 42 degrees, opposite and adjacent are what I have. Which trig function should I write? Tangent. All right. Tangent. So we have the tangent of our 42 degree angle is opposite over adjacent. So 174 over x. So opposite over adjacent. Once again, I'm going to cross multiply. I get x times the tangent of 42 equals 1 times 174. And how do you get x by itself? Divide by the tangent of 42. All right, 174 divided by the tangent of 42 is 193.2 feet. Very good. 190, oh, just kidding. What the heck? Oh, I didn't get, I forgot my 1. Do you see that? I forgot my 1. There we go. 193.2. That's better. That is not what that says, is it? Oh, got a little typo there.
I just changed the problem on you. I was doing them.
Did all the problems that I'm getting, we haven't even done one of them.
All right, Zach is standing at the top of the lookout tower. So Zach is standing right here at the top of the tower and spots a water fountain below. If the lookout tower is 75 feet tall, so 75 feet tall is my tower, and the angle of depression is 28 degrees. So from horizontal, he has to look down 28 degrees to see that fountain below. So there's that fountain. What is the horizontal distance between Zach and the water fountain? So we want to know this distance, the horizontal distance, x. All right, I have that 28 degree angle, but it's outside my triangle. What should we do? Where? Bottom right, yeah, again, we have alternate interior angles because our horizontal lines there are parallel. So we get that Z shape, so this is also 28 degrees down here. And so now that we have that angle inside the triangle, I have the opposite side and adjacent side, which is another tangent function. So the tangent of 28 degrees, that is just a coincidence. Not every problem is going to be tangent. Opposite 75 over adjacent x. So 75 over x. All right, I'm going to cross multiply. Once again, we get x times the tangent of 28 equals the 75. And how do we get x by itself? Divide by the tangent of 28. All right, I'm going to try to type this one in correctly now. 75 divided by the tangent of 28. And I get 141.1 feet. All right, questions for me?
I have a question. Yeah, so, I was doing a problem, and it switched the whole problem, and then I hit enter, and it switched the whole problem.